Thank you for coming today. We will be discussing how to apply Le Chatelier's principle. Le Chatelier's principle states that if a dynamic equilibrium or system is disturbed by changing the conditions, the position of equilibrium moves to counteract the change. Before continuing further, we must understand exactly when a reaction is in dynamic equilibrium. A dynamic equilibrium occurs when the rates are equal for the forward and reverse reactions and the concentrations of both the products and the reactants remain constant. However, this does not mean that the concentrations have to be equal. We must also understand what a reactant quotient is. A reactant quotient is a measure of the relative amounts of products and reactants present in a reaction at a given time. The equation below is where the formula for Q is derived, allowing us to see how the coefficients become exponents for the concentrations as well as for the partial pressures. Now let us do an example to help you test your understanding of how to find Q. Using the formula provided, we can put the product in the numerator and the reactors in the denominator. We can find their exponents by using the coefficients of each component in the balanced equation. We must also understand what an equilibrium constant is. An equilibrium constant is the constant value of Q exhibited by a system at equilibrium. The equilibrium constant K is also represented by the following formula. Now let us solve an example to test your understanding. Find K for the following reaction. The concentrations of each element are given. Using the formula below to solve for K, we can set up the equation with the product as the numerator and the reactants as the denominator. We can then proceed to plug in the concentrations and solve for K, which we learn is 2/9. If the value of K is larger, this means at equilibrium there is a higher concentration of products and a low concentration of reactants. If the value of K is smaller, the reverse is true. At equilibrium, there will be a higher concentration of reactants and a lower concentration of products. The first disruption that we will be discussing is the change in concentration. Adding a reactant causes K to be greater than Q and shifts the reaction to the right in order to establish equilibrium. Removing a product causes K to be less than Q and shifts the reaction to the left in order to establish equilibrium. Adding more A increases the probability for the reaction to occur between A and B, lowering the amount of B because more B's are going to be consumed. As a result, C's and D's are being increased, causing the forward reaction to be faster than the reverse reaction. It is going to favor the right in order to re-establish equilibrium. Removing C causes the reverse reaction to be faster than the forward reaction, increasing the amount of A's and B's produced, causing it to move to the left in order to reestablish equilibrium. When you stress a reaction that's in equilibrium, the reaction will favor the side that is unstressed in order to undo it. Next, we will address change in temperature. We are stressing this reaction by adding heat, increasing the speed of the forward reaction. The reaction is going to favor the direction that relieves the stress and shifts the reaction to the right. Because this is an endothermic reaction, there is a direct relationship between the temperature and the value of K. This direct relationships mean they will follow a same pattern, whereas inverse relationships would have an opposite pattern. Likewise, decreasing the temperature decreases the value of K, shifting the reaction to the left instead of the right. And in an exothermic reaction, heat is released. There is an indirectly proportional relationship between temperature and the value of K. Decreasing the temperature increases the value of K, shifting the reaction to the right, and likewise, seen in the example, increasing the temperature decreases the value of K and shifts it to the left. Finally, hang in there guys, we're almost done. Change in pressure is the last disruption that we will discuss. We will use the following balanced equation to discuss this disruption. Increasing the pressure of a reaction decreases the volume of the reaction due to their indirectly proportional relationship described by Boyle's law. This applies to the reaction because we must find a way to relieve the stress added by the application of pressure. Lowering the number of molecules relieves the stress. We go from 3 molecules of hydrogen and 1 molecule of nitrogen to 2 moles of ammonia. The reaction is going to favor the side with less molecules because there is less pressure. Thank you so much. I hope you have a better understanding of Le Chatelier's principle.